Hello friends, this is Sagar. Welcome back to my YouTube channel. I hope you're doing well. Stay tuned till end.
Today we will discuss about how to study building construction drawings. Stay tuned. Don't forget to hit that subscribe button and turn on the bell notification so you never miss an update. Let's dive in and have some fun. Studying structural drawings in AutoCAD involves learning how to interpret, create, and modify detailed plans that represent the framework of buildings or infrastructure. These drawings typically include various components such as beams, columns, foundations, walls, and floor systems, among others. To guide you through this, here are some key steps to follow. 1. Understanding structural drawings basics. Symbols and notations. Structural drawings use specific symbols to represent materials, elements, and systems, e.g., steel, concrete, etc. Familiarize yourself with these symbols as they are critical to interpreting the drawings. Scale. Drawings are often created to scale, so understanding the scale used, e.g., 100, 1:50, is important to interpret the size of elements correctly. Types of structural drawings. Foundation plans shows the layout of footings, slabs, and the foundation system. Framing plans indicates the placement of beams, columns, and floor systems. Detailed drawings, detailed sections showing how components come together, such as connections between beams and columns. Rebar detailing, specific drawings for reinforcing steel placement in concrete elements. Though working with AutoCAD for structural drawings. Layer management, AutoCAD uses layers to organize different parts of the drawing, e.g., one layer for beams, another for walls. Learn to manage layers to ensure clarity. Blocks and references, you'll encounter common symbols and repetitive elements like windows, doors, or steel reinforcements. Use AutoCAD's block feature to insert standardized components and XREFS, external references, for attaching entire drawing files. Dimensioning, properly dimensioning your structural components is crucial. Use AutoCAD's DIM tools to add measurements to the drawing accurately. Drawing tools, master tools like line, polyline, hatch, circle, arc, and rectangle for creating the different parts of your structural design. Annotations and text. Structural drawings usually have a lot of annotations for materials, quantities, or specific instructions. Use AutoCAD's MTXT and DTXT to add notes, along with leaders to point to specific details. Theme: creating structural elements in AutoCAD. Drawing structural components. Beams and columns. Draw beams as polylines and columns using rectangle or polyline tools. You can use dimensions to ensure the correct size and spacing. Foundation and slabs. Use hatch patterns to indicate concrete or other materials. Draw the boundaries of foundations using lines or polylines. Details. For specific structural details, like the connection between a column and a beam, use section views and include reference symbols. Use of hatch patterns. AutoCAD allows you to use different hatch patterns for materials like concrete, steel, etc. Make sure you apply the correct hatch pattern to represent the materials used in the design. JAR: creating a structural plan in AutoCAD. Start with the layout of the floor plan and position the structural elements, beams, columns, and walls. Add annotations for dimensions, material specifications, and details. Use the XREF tool to incorporate other related drawings, like architectural or mechanical drawings, that integrate with the structural design. Ensure everything is to scale and accurately represents the real-world layout. 5. 3D modeling of structural elements, optional. If you want to study or create 3D structural models, AutoCAD has the ability to create 3D objects. Use tools like extrude, revolve, and sweep to model elements like beams, columns, and slabs in 3D. You can also use the 3D view option to rotate and visualize your design in 3 dimensions, which can help in understanding the overall structure. Review and quality control. Cross-check with codes and standards. Structural drawings should comply with local building codes, like AISC for steel or ACI for concrete. Make sure all components meet those standards. Clash detection. If working with multidisciplinary teams, e.g., architects, MEP engineers, ensure there are no conflicts between the structural elements and other systems. SAT using AutoCAD's advanced features. Dynamic blocks. Use dynamic blocks for structural components like doors, windows, or beams that may have varying sizes. This helps in saving time while modifying the drawing. Parametric constraints. Apply parametric constraints to define relationships between different elements, e.g., a column height could automatically adjust based on the floor-to-floor height. Art, exporting and printing. Once the drawing is complete, you will need to output it for sharing or printing. Use layouts in AutoCAD to set up your sheet size, title blocks, and scales. Export drawings in PDF or DWF formats for easy sharing and printing. Resources for learning. Online courses and tutorials. Websites like Udemy, LinkedIn Learning, or Coursera offer structured AutoCAD courses focusing on structural design. AutoCAD user guides, Autodesk's official guides and forums can help clarify any technical details or features you are unfamiliar with. Structural engineering books, textbooks like Design of Reinforced Concrete by N. Subramanian or Structural Steel Design by Jack C. McCormack provide in-depth knowledge of the principles you'll be drawing. BBS, bar bending schedule. Reinforcement refers to the detailed schedule used in structural engineering and construction to outline the type, size, quantity, and placement of reinforcement bars, rebar, in a concrete structure. The BBS is crucial for ensuring the correct placement and cutting of reinforcement bars according to the design specifications, which helps maintain the structural integrity of the building. Key elements of a BBS, bar bending schedule. Bar mark. This refers to a unique identification code assigned to each type of reinforcement bar. It's used for easy reference in drawings and during construction. Bar diameter. This is the diameter of the rebar, usually in millimeters, e.g., 8 mm, 12 mm, 16 mm. Bar length. The total length of the reinforcement bar required for a particular element. This is often given in millimeters or meters. Quantity. The total number of bars required for a given element, such as beams, slabs, or columns. Shape. The shape or bending details of the reinforcement, often shown with bending diagram. This includes the required bend angles, radii, and the position of bends along the length of the bar. Cut length. This is the length of the bar after it has been cut, which can be different from the bar length due to the bending process. Hooks and bends. If the bar has hooks or bends, such as 90-degree or 135-degree bends, the schedule will specify their size and location. Weight of each bar, calculated based on the diameter and length of the bar. This helps in estimating the total weight of rebar needed for the project. T-bara means the diameter of the bar is 12 mm. Quantity refers to how many pieces of the bar are needed. Length refers to the required length of each rebar. Shape specifies whether the bar is straight or bent, and the details of the bends. Weight is the calculated weight for each type of bar. Steps in preparing bar bending schedule. Review structural drawings. Go through the structural plans and identify the reinforcement requirements for beams, columns, slabs, and other structural elements. Bar identification. Identify the type of rebar used and the diameter as specified in the structural design. Measure dimensions. Measure or extract the dimensions from the drawings for bar lengths and positions. Bar bending details. Determine the bend angles, the length of the bar, and whether it requires any hooks or other specific shapes. Prepare the schedule. Organize all the information in a table format to clearly specify the type, quantity, and placement of each bar. Common bar bending shapes. Straight bar, no bends, used for straight reinforcement. 90-degree bend, used for anchor points or where the bar needs to turn. 135-degree bend, a more gradual bend for anchoring or turning reinforcement. Hooks, used at the ends of bars for anchoring them in concrete. Importance of BBS. Accuracy. It ensures that the right amount of reinforcement is used, and it's cut and bent according to the correct specifications. Efficiency helps reduce material wastage and